Okay. Good afternoon. So today we just review what we have learned after midterm examination, right? So the details, chapter 6. Yep. So, about the basic SQL. Can you remember anything? Right? And of course, you have to remember schema of the SQL command. So, what can we do with the database? What can we do with the table? What can we do with the data instance? Okay. Create schema, create table, create database. And okay, I think in the examination, of course, we will have this kind of the schema of the relation, right? After that, we use that kind of schema to retrieve the data from some questions that we have from our customers, like a requirement for the page, one page of the data that have some report. And the report, we need the name of the employee who has salary more than 50,000, for example. So you have to create the SQL command. And you have to at first you have to understand the relation between table at first, and then you have to know what kind of the table related to the requirement, and then you create the SQL command based on the tables. Okay. So okay. Maybe I will try to give you this kind of the example data also, so you can you don't have to imagine what kind of the data is quite clear. Okay, this is the example of the create table. So you just have to know about the schema of them. What does this mean? For example, here, what are they? They just the name, right? The name of the field in the table, and where they come from. Of course, they're from the ER diagram. From the ER diagram, you have to transfer it, change it to the relational model, and from the relational model, you have to transfer it, change it to the command, like that kind of the create. Right? Here is also not now. What does this mean? Why? It's not now. Sometimes it's just the key. Sometimes it's just not now because they don't want this now. They need some data inside. And the key concept. Key. Can you remember anything about the key? At first, we have to define super key, right? Super key, and then we try to identify candidate key. After it's become candidate key, we select them, one of them to be the key, a key, primary key. The other one become secondary key. If you can imagine what kind of the concept of that, so it's no problem for you. If you still confuse it, please review. Please review. Okay. Create table. Okay, this is create table. And the data type, what is different between them? Numeric, characteristic, fixed length. So please understand the concept of them. Bit, string, boolean, date, nothing. Timestamp. You know the timestamp, right? Timestamp is just the server time. And when you insert the record, they use the server time as a timestamp when the data are recorded into the database. That's all. But if you use date and time, user have to insert them. to the database. But if you use timestamp, it automatically store the data for you. Okay. And the domain of the data. Okay, you can create the domain for one, because sometimes you have the specific domain and some specific requirement for this domain. So you just create the domain once, and then you can refer to this domain when you create a new table. If you have several tables, use the same domain. You don't have to define it every time. You just use one of the domain. For example, this is a domain. Also, if you have the specific like name of some product, right? How to specify the name of the product, like just 10 characters with only character without any numeric, something like that. You can define them in details, and you just set it just once, and then when you create a table that refers to the product name, you just refer to the domain that you already create. So it's quite convenient, and try to get rid of the mistake from the human error. Okay, we also have the key, primary key, okay, and entity integrity. Okay, so we have this concept of the constraints that very important, because if I will ask you what kind of the problem in the design, for example, we have duplicate in the key. What is happen? For example, entity integrity, we have primary key. If you not define the primary key, some of the key will have duplication and will have problem. So that is entity integrity. So all of them, please understand very clearly about the concept. And if you can give me some example, okay, some example might be better. And how to solve it. If you found a problem in the design, what kind of the example of the problems and how to solve it? I said it twice, right? Okay, let's try to imagine how to do that. Okay? And what else? Check clause. Here, primary key. What is primary key? Sometimes the data is just defined to be unique. If it's unique, of course, it can be a key, right? But if the column is unique but not selected as the primary key, then it becomes the secondary key. What is the foreign key? Okay. And foreign key refer to the referential integrity. So you have to understand what is referential integrity. It's refer to the other table, right? So when it's become the problem about the referential integrity, if you can give me some example when it will come against this kind of integrity, when, and give us some example. Okay. The name, constraint. Specify, create table. When you create a table, of course, you can add some check. Check is like a condition for the table. Here, if you create a table and you can add the check, for example, here is department created less or equal to the manager start date, right? If the manager start date is less than, so someone become manager before you create the department is impossible. Okay. Select statement. Here is the basic form. Select from where. Here, select from where. It's very simple one. So, but of course, my question is not simple like that. So you have some complex requirement from several tables, and you have to add the condition, a lot of conditions to meet my requirement. Okay. So the operation that we can use, logic operation, and not equal, you use this one. Okay, use this one. Not use the, not like in Excel, right? He used the big remark. Oh, no, not English. Big remark, another show. Okay, up there. Okay, this one in, maybe in Python and also Java we use this one, right? But in SQL command we use the other one here. In SQL operation, not equal here, not equal. Okay. Anyway, or I give you the SQL command and you give me the requirement, opposite side. Maybe it's not so difficult if I give you the SQL command, right? I will try it several ways. And it's become complex, more complex. If you need, this one is already complex one because we have to use 3 tables, right? Here, every project location in Stanford lists the project number and the control department number and the department manager last name, address, the birth date. Okay, so at first you have to analyze the requirements and what kind of the table related to these questions, and then you just try to mapping the foreign key. What kind of the foreign key we have to use, right? And you have to simulation in your head what kind of the table will show in the final result. Okay. So you have to practice a lot if possible. Please try to use the example data and do it for real. It's quite better. Or you can practice in the try to understand the relation between tables, and then you try to run your SQL command to retrieve the data. Maybe you can set up your question by your own, or use GPT to generate the questions for you, and you try to find the correct answers. Okay. Have you ever tried this one? The W3 schools? Yeah, this one is a good one, and very simple, from simple to complex. Here is joy, inner joy, left joy, right joy, full joy. Okay, union. You can use anything. Okay, although it's not in the slide, that's fine. I will try to understand what you're going to do. Ambiguous. Okay, nothing. Here, to reduce the confusion, they use the name of the table in front of the attribute name. Here, department is table name, right? Dot name. This means we use the attribute name attribute name from the table department. But here, then they show in the result table the name not from the department but from employee table. Different table. Okay. And here also, because both of the table use the department number column, similar name, B number and D number, if you don't identify the name, where is the D number from, is become confused because the sentence become D number equal D number, right? If you don't have this one, department, the program also confused, and also I will confuse. So please identify what is the number from, or if you don't want to write it for long, you can define the alias name in behind the full name, and you just use the alias. For example, the other one may be here. This one, alias. Here, employee SE, employee SE is from the same table. Okay, so this kind of the SQL command is like duplicate employee to two tables and use them, join them together, because this one is from the self relation. Here they want employee first name, last name, and the supervisor name. If you can remember the schema of the employee and the supervisor, not schema, ER diagram. So the employee, we have attribute, right? The attribute have the self relation to itself, the supervisor relation. So you have to use the same table to retrieve the data, and you have to duplicate them and set this one, the alias name, different. So the program can understand, you select from E or from S, they are different. When the program look at this command, they look the employee table, two tables, and they are different. This is very important. Actually, it's quite complex one. Okay. Yeah, this kind of the question might be good to separate the people who understand or not understand. Right? Okay. The other one you can, this one is change the name, rename. You can rename everything. Employee as E. E is a table name, right? That you can change from employee to just E. And inside them, you can change all of the column name to shorter one or longer one as you want. Okay. And the results show the name of the column as the new one. So please try to create your own query and then create a SQL command from your query. This one shows just star. We want just everything, right? If we want just some of the column, we call projection. Right? Okay, if you use star, you select all of them. On salary. Okay. Actually, the important one is distinct. When we have to use distinct, when we have duplication data and they don't want to show all of them, we just want to show the unique of them. So we use the distinct. Here, for example, select distinct salary from employee. Actually, you might have several people have same salary. If you just print it out, you have like 10,000, 10,000, 10,000, 10,000, but you don't want to know all of them. You just want to know what kind of the type of the salary or range of them roughly. So you use just this thing. So the 10,000 will show you just once in the results. Except intersect. So when you using this kind of the concept, set operations, of course you have to understand the set operation at first. What is union? What is the exception? What is the intersect? So from this command, you can imagine that this is one of the set of the data. And here is union, right? The other one here in this bracket is the outer set of the data. But when you go into union or do something in set operation, you have to check it. Both of them are union compatible or not. What is union compatible? Same number of columns, same type of columns, okay, and the same name of the columns. If not, you cannot join, not union, you cannot use the set operation. You have to check union compatible. If two tables have different number of the columns and different domain, so when you want to union them, you have to just select the similar one, the similar set of the attributes, and when you change them to union compatible, after that you can join them, union, or use the set operation between them. Like it is for string, right? String. Use person in front of the string. You can have the all string that have this. Here is the person in front of and behind, right? So in the address, if you have this part of string, the result will show all of the result that include this part of the string. And you can also use underscore here. Yep. For string operation. And else, arithmetic operation plus add, subtraction, multiplications, division. So when you want to increase salary for the whole employees, you just multiply them with the percentage, okay? And then you can replace it in the update. We're not talking about it. You can update it in your table at once. You just multiply them and then add update to the old data. So if I have the question to ask you to update the whole salary for the company or give the bonus, something like that. So give all of them 5% increase. Can you imagine what kind of the command we have to use? Not easy, right? Anyway, actually you can use just one command. Update something inside and you just add the arithmetic operation inside. But if you cannot remember, you can do just select and have some arithmetic and store them in the temporary table and use the temporary table to update to O1. That's fine. Okay, you can use several ways, depends on your style. Okay, let's break a little bit. Cost evaluation. You have to evaluate me before I evaluate you. Okay, ครับเชิญครับพี่แนน
this QR code. You need to log into SIT Wi-Fi before, and then you scan this QR code and do it online. You finish? Okay, thank you.
Let's see the name or the project name, for example. And also you can use here to manipulate your table, to update your table, insert, delete, update. And you can modify your database. So this is an example of them. Insert. How to insert the data here. Yeah, of course, you just select, insert into the employee table, and you just add the value. But the order is very important because the computer cannot know what is the Richard means. They don't know the meaning. So you have to order correctly, align with the name of the columns inside the database. Okay. And you can also select from the other table and then insert into the new one. This one, they just select, insert into works on info. This is a new table that you have to create. And then the data is from the select command here. And the result of the select command we insert into the new table automatically. So it's very convenient. And then here, and this one. Okay, what else? Delete. How to delete? Just insert delete from the table name, and then you have to insert some condition. If not, what is happening? U4D, what is happening here? You delete all of the data inside employee. That's all. But the structure or the table schema still remain. If you don't want the table anymore, you can have to use the other command. Do you know which one? Drop. Drop the table. If you don't want database, you just drop database. Don't do that, please. Please back up before you do that. If you want to try to use the command, just back up it before. Okay? Backup, so backup is very important. And update. You can change the data inside, and that means update. So you have to insert some condition. For example, here, just update the project name number 10 with the position, something like that. Or here, as I tell you before about this kind of the requirement, if we want to give our employee in research department 10% raise in salary and update in just once. Okay, you just use this command, update employee salary equal salary multiply 1.1 here. Say, you can change the salary of the employee in the department research, all of them. Okay, this kind of the command. I think you can do it. Okay, so please try to understand this kind of the structure of the SQL command, how to do that just once. If you can do this one, it's quite look so smart. If not, that's fine. You can separate them. Just select them and store them in the temporary table and use the data in temporary table to update the data in the table of the employee, for example. Okay. Anyway, please try to understand this kind of the update command. Okay. So here is just left join, right join. If you use outer join, what is happen if we have some now value? Okay. And here set operation is not now. Yep. And here is some of the complex SQL query that you have to understand the structure of them and how to combine this kind of the command together, like select or select something like that. Here is we call nest SQL anyway, so that's fine. But you have to understand what kind of the requirement and how to retrieve the data to meet this kind of the requirement. So imagine is very important here. Here is tuple values in comparison. Oh wow! Place them within parentheses. Oh, they changed them. Just one. Oh, this one is quite easy one. Just select the ESSN here, and what is happened? The result will show P&O and hours, and we just show the other person who works in the same pattern as this man, right? Yep, this is the example of the nest query. Here is nest query is here. Query inside the query. This one the query inside query. We call nest query. So this one also we can use the comparison, right, operation to compare the result. For example, here the compare the result of the salary, right, from this command we will show. If you can imagine, this one is shown not just only one value, it's become one table, but the table has just only one column, salary, and then they try to find the other person who has salary more than the set of salary inside the nest query here. So okay. Of course, you can use query inside query. So you can use like a hierarchy if you want to do some complex one. But if it's like too difficult for you, you can separate the operation and use the temporary table to make the complex operation. Okay. So it's just a nest, very complicated one already. And then try to remember to use this one, alias, to shorten the name of the table. When you write the command, you'll be more clear in the command, and you will not get confused when you have some long SQL command. Here is exit. Exit. You can use exit also. What else? In. Of course, in. You can use, for example, here P&O in the set 1, 2, 3. If you don't want to, like a hard code in 1, 2, 3, you can use the command, if you have the command, to select the result from the other table. But you have to understand that the set of the command have to union compatible or the same domain as the P&O. If not, you cannot compare the P&O with the SSN. You cannot compare P&O with the name of the person, for example. So the inside of the set, if you use in the set here, have to domains equal to the outside one. Okay. Join. Join. How to join? If you want to use join, one thing you have to know that we need foreign key, right? If you don't have any foreign key, what is happen? It just become Cartesian product. no meaning. Okay, when you join, if you use natural join, the program will find the key and the foreign key or the similar domain of the column, and then the program will use the similar one to join two tables together. And we also have left join, right join, and full join, outer join. So you have to understand the difference between them: inner join, outer join, left join, right join. What are they? And what kind of the result will show in the final table? Maybe I will give you some example of the table with now, and then I ask you to join with the right join, what is happen, or just outer join, what is happen. You just show the result, what it should be. And we also can use this kind of the aggregate function, count, sum, max, mean, average here. Remember that when you use this kind of the function, the result becomes just one line, one result. So you have to imagine when you use this kind of aggregate function with the general function. If general function, you will have several lines, right? That if you get aggregate function with just result one line and combine with the other command with several lines, it becomes error and the result will not show. So when you use the aggregate function, you have to use them together. Okay. Here is just the result show just one line. You cannot use sum, salary, and the name of the people. You cannot do that. Okay, you cannot mix it up. If I ask you to create the command to show the summarize of the salary and the list of the name of the employee, what should you do? One thing, you just write down. I cannot do that. But the other thing, you just give me some comments that, we have to separate them to two tables. The first one, just summarization of the summary of the salary, and the other one is a list of the employees, right? We can have some discussion in the examination, okay? You can write the reason why you cannot do that. Please not say just, I cannot do that, okay? If you just say that, nothing happened, just zero. You have to give me some reason why. And plus solution, okay? If you think my examination has some problem or some questions, you can call me, but sometimes I come so slow or not come because of some communication loss. So you just write down what you understand about my question, and if you think anyway, I will read your explanation and the result of the explanation, and I will try to give you the score, of course. Okay. If you found some ambiguous, you just explain what you understand, what kind of the idea that you get from the question, and you just give me the solution of the question. That's fine. Okay. What else? D and O. Oh, this is different. We can use the here is group by command. We can count, of course, separate by department, and don't forget the group by. If you don't have group by D&O, you just have two lines here. The results become error, okay? Don't forget group by if you want to separate to show the result of count and average salary for each department. Group by is really important. Here is more complex one. You have having also. If you can understand this one, the previous become easy for you already. Okay, what else? We can separate in a case. Okay. So maybe the trigger. Okay, you just understand the concept. Maybe that's fine about the trigger. The trigger. Create a view. Not so different from the SQL command, but you just add a little bit the name of the view. That's all. Okay. Cascade drop. Roughly about that. The main concept of this one is the join and nest query. Right? We have query inside the query, and also some outer table insert, update, delete command for this slide. Your project already. Then you have the ER9. Sorry, I skipped this one. 8, chapter 8, algebra. Algebra. We don't have any calculus. Sorry about that. I think it's too much. Join and division. I like division. Okay. I will try to challenge you. Okay, let's try to understand the division also. If I give you the schema and ask some, actually, if I give you some requirement like this one, select employee tuple whose department number is 4. So you can write here the algebra. Sigma D and O equal 4 from table employee, and also you can, I think you can do it, change it from algebra to SQL command, right? It's very simple. And this is the concept of the unary relational operation of the select. Okay, we select with two conditions. We can change the position of the conditions, okay? And you can also use and also. So that here is pi. Pi is projection. Change the name. Just change the name. Nothing. Change the name of the table. Here is, if I ask you to explain, can you do that? So in this one, you just select the employee from the table employee with D&O equal 5, and then you change the name of the result table to be the F name, last name, and salary. That's all. Here row. Sorry. P is projection, not change the name. Sorry. Projection. Just cut it for the result that you want. If the employee has long attribute, 10 attributes, you just show in the result just 3 of them. P projection, right? Projection. And the other one, I is rename. Change the name of the table. Change the name. Here, for example, here you has the department M, something like that, and the result you want the name of column F name, last name, salary. You can use this kind of the command, of the algebra equation. Okay. Union also nothing, just reset of the union. You can use this kind of the operation, like you select D&O 5 from the table employee, and then the result store in this parameter def5m, actually this temporary table, and you can select it as XSN or project the SSN from the result and store it into this parameter result 1. After that, you union with the other result, that's fine. Okay. You don't have to do it at once. It's too complex and too long algebra and quite difficult to understand. You can separate into several lines. Okay, the other one is just operation union intersect different. And here is join, the bow join. If you don't have anything, it's natural join, and join with. If you have some condition, you have to add the join condition here. And the symbol of the okay, here is the join operation with condition with theta. Sometimes we call theta join. Theta join, and the condition can be use the logic operation also, like and. You can use and or less than, equal, something like that. Here you can add some condition also. And natural join. Natural join. Before you can join them together, you have to check it that they have the similar domain of the column or not. If not, it's quite you cannot do that. You cannot join them together. Okay, here is the auto operation and division. And you have to understand this kind of the example of the division, right? Please review it. And what else? Auto join. Where is auto join? Hurry. Hey? You don't have auto join? Auto join is here. Yes. This symbol, don't forget it. This is left join, right join. Here is the full auto join, and the result is like this one. When you use some join, left join, auto join, we have some now in the result. When this happen, you have to review it. What else? Of course, the examination will like this one. Retrieve the name and address of all employees who work for the research department. Then you have to here write down the solution of the algebra, how to retrieve the data, and decide the command using the algebra. And the same question might be asked for the SQL command.